Assalamu alaikum wa rahmatullahi wa barakatuh, Shabab Sabaya. Today we will talk about chapter 10, which is about temperature and pressure. So in this chapter, I will talk about two subjects. First one, which is about temperature scales. So we have three temperature scales: Celsius, Fahrenheit, and Kelvin. As an example, I will take the temperature for water, either boiling or freezing point, as you can see here in Celsius, Fahrenheit, and Kelvin. Now, our problem is how to convert from scale into other or another scale, which we can see here from Celsius into Fahrenheit. We have this formula and vice versa. So this formula can convert the temperature from Celsius into Fahrenheit or from Fahrenheit into Celsius. Second, convert from Celsius temperature into Kelvin, as you can see here. And be careful, this formula too, we can use it in order to convert from Celsius into Kelvin or Kelvin into Celsius. As an example, I have, or on a summer day, the temperature is 95 Fahrenheit. What is the temperature in degrees Celsius and Kelvin? You know what? I will go to the second part, which is converting from 95 Fahrenheit into Kelvin. We know there is no direct relation between Fahrenheit and Kelvin, but we can see here the temperature in Kelvin equal temperature in Celsius plus this constant. Now, from this formula, it's obvious we have to convert from Fahrenheit into Celsius, which is in part A. So temperature in Celsius, as you can see here, after we convert it, it's 35 Celsius. So the temperature in Celsius is 35. Therefore, we can all the way substitute in this formula. So as a summary, I have a temperature in Fahrenheit, and I'm going to convert it into Kelvin. First step, you have to convert it from Fahrenheit into Celsius, then from Celsius into Kelvin. Second subject in this chapter, which is about pressure. Pressure is the force applied perpendicular to the surface of any object per unit area. As you can see here, this is the surface area, and the force here is perpendicular into the surface area. Therefore, mathematically, we can say the pressure is perpendicular force divided by area in unit of Newton per meter square. Be careful, Newton per meter square as a unit, in SI units, it's 1 Pascal. Now, you need to pay attention to other units of pressure, either atmospheric pressure or millimeter mercury or bar or inch. And yes, you need to know how to convert, for example, from bar into atmospheric or from millimeter mercury into torr. In general, let me say this is my surface area and this red arrow is the force, and clearly the force here has an angle. Therefore, you have to resolve your force into two components, one along horizontal line and one vertical or perpendicular line. And clearly, F sine is my force or my perpendicular force to the surface area. So the pressure here will be F sine theta divided by area instead of F divided by A. Second case, I want to change the position of the angle, as you can see here. Therefore, the perpendicular force is F cosine instead of F sine, and the pressure will be F cosine divided by A. In general, I would like to do a quick review before going to the examples. First of all, we know the weight, which is mass times gravity in unit of Newton. And we know the volume, which is length times width times thickness or depth in unit meter cube. And finally, we know the density is mass divided by volume in unit of kilogram per meter cube. Okay, let's go to our first example. The mattress of water bed of dimension 2 meters by 2 meters by 30 centimeter in depth. What is the weight of the water in this mattress? We know the weight is mass times gravity. Gravity is 10 meter per second square, but the mass is unknown. How to think about this problem? Obviously, here we can see the dimension of my mattress, which is 2 meters times 2 meters times 30 centimeter. This can help me out to find the volume. So if I have the volume and we know the density of water, so easily we can use this formula where the mass equals rho times V. So from this formula, we can calculate mass and we know the gravity. So all what you have to do, just substitute the amount of mass and the gravity to get the weight. And be careful, here the weight has a direction all the way down. Now, second part, find the pressure exerted by the water bed on the floor when the bed rests on its normal force, or sorry, when it's rests in its normal position. In other words, this is my mattress, and I can look at it as the following. Take the interior lower surface of the bed and has a contact with the floor. Therefore, the weight of the water will be all the way down. This F should be W. I'm meant here the weight. So clearly, the weight is perpendicular to the surface area, and therefore we can say pressure equals W divided by area. Second example, someone steps on your toy, exerting a force of 500 Newton on an area of 1 centimeter square. What is the average pressure on that area in unit of atmospheric units? Be careful. I'm asking you here to calculate the pressure, but in atmospheric units. Okay, in general, pressure equal force divided by area. We know the force, which is 500, and the area is 1 centimeter squared. Be careful. Here, the unit is a centimeter squared. You have to convert it from centimeter squared into meter squared, which is divided by 100 squared. So do your calculations. You will find the pressure 5 times 10 to the power 6 Newton per meter squared, or Pascal. But the question here asking me to find it in unit of atmospheric units. So we know one atmospheric unit equals 10 to the power 5 Pascal. So do your calculations. You will find the pressure is 50 atmospheric units. New subject, or let us continue to this subject, which is gauge pressure. In general, if I have a cylinder and filled this cylinder with certain gas. Therefore, I can measure 3 types of pressure for this system, where the pressure from outside is the atmospheric pressure. The pressure from inside, which is the absolute pressure. The third pressure is the difference between the pressure inside and outside, which is the gauge pressure, as you can see here. Be careful too. The inside the pressure is the absolute pressure, and the gauge pressure is inside the pressure minus outside pressure. Now, let we say we know the inside the pressure and we know the area. Therefore, we can calculate the force due to inside pressure, where F inside, or the inside force, equal inside pressure times area. Let's go to this example. A certain gas at a pressure of 10 atmosphere is in a cubical container of size 0.1 meter. If the pressure outside is the atmospheric pressure, first calculate the force due to the gas inside or the inside pressure. We know pressure in general equals to force, perpendicular force, I mean, divided by the area. Therefore, force equals to inside pressure times area, as you can see here. Second part, calculate the force on the outside due to the atmosphere. Okay, same procedure. Pressure outside equal the perpendicular force from outside divided by the area. Now multiply both sides, you will find F outside equals outside pressure times area. Third, or what is the net force on one wall of the container? So technically we are calculating, or we are going to calculate the difference between the forces inside to outside. In other words, F net, which is F inside minus outside force. Thank you and see you next